Today we are going to see pulley based questions, the most commonly asked questions, and these are the tricks which are going to be seen over here. We are going to see how easily we can solve them by just using certain formulas. The first one is where a pulley is attached to two masses. Okay, suppose we give them as m1 and m2. The acceleration can be easily found using this formula. The value of g you can put as 10. Instead of m1, put the heavier mass. If you put the lighter mass as well, just when you subtract, you get the negative sign. Just ignore the negative sign in the final answer, okay? If you get the final answer negative, just ignore it. Don't worry whether you're putting m1 or m2, which value, okay? Just label any one of them and solve. Tension also in the string, the tension which is acting over here is the same tension acting over here, okay? Because the string is same. But the tension acting over the pulley is said to be 2 times of the tension acting in these two strings. After this question, the next question, which is also on the similar basis, is where there are two masses attached in 3 and 4. You can consider this as 7 and solve, okay, rather than taking individual. So this is m1 suppose, and this mass would be taken as m2. Next is, after that, the next question over here is this one, which is most commonly seen, where one mass is placed on the table, another is hanging downwards. The acceleration can be found out using this formula and tension using this. Here the important thing is the mass m2 is the one which is hanging downwards, okay? M2 is the mass which is hanging downwards, not the heavier mass. Therefore here m2 would be written. And similarly, this is the only thing that we need to remember in this type of question. Just put the values and solve the question, nothing else is required. The next type of question is seen in this type, where masses are attached on either sides, okay, and there is the common mass m3 over here. We'll consider the heavier mass m2 and the lighter mass as m1. Just put it in this formula and you'll find the acceleration, okay, of these blocks together. But here tension formula is not given. Why? Because this string is different, okay? This is one string where T1 tension would be acting, and this is the second string where T2 tension would be acting. As a result, we'll individually find. How we'll find? This is 4G acting downwards, and here T1 tension is acting upwards, okay? One thing we need to remember, object moves in the direction of heavier mass. So this is the direction of acceleration. 6 is heavier, so here it would be moving upwards. Just make the lines moving in one direction, okay? Now the direction in which acceleration is acting, we'll take it like this: T1 minus the 4g, okay, that is mass into acceleration, that is the force. This is the force which we have written, multiplied by 4 into acceleration. So this is the way through which we can find T1. Similarly, T2 can be found out. Here down 6g is acting, okay, force into acceleration, and here we'll write as 6g minus T2. T2 will be acting here, will be equivalent to 6 into acceleration. So this is the method through which tension over here would be found out. Here no direct formula can be used, only for acceleration the direct formula is there. This is the similar formula which was seen above, where only one block was present hanging and one was downwards. Only additional thing, m3 is written in the denominator, rest all things are same. After that, the final type of question which is mostly seen to be asked is where two blocks are present on a inclined slope, okay? See, this is the mass m1 suppose, and this is the mass m2, okay? The angle which is present at m2 will take it as beta, and at m1 will take it as alpha. Easily we can find the tension over here, okay, through this formula, just including this, and in acceleration also similar manner we can use this formula. Rest all things are same. No other points need to be mentioned over here. Easily tension, acceleration. Tension is present in this string, also in this string is same because the string is same. So in the same string, tension remains the same. And alpha beta need to be remembered. The mass m1 has alpha, m2 has beta. The rest all is covered.